Imagine if humanity could harness the full energy output of our sun, unlocking a virtually limitless source of power. This is the grand vision behind the concept of a Dyson Sphere, a hypothetical megastructure that has fascinated scientists and science fiction enthusiasts alike. But what exactly is a Dyson Sphere, and could we, with our current technological prowess, ever hope to build such a monumental construct? The journey begins with the visionary British-American physicist and mathematician Freeman Dyson. In 1960, Dyson published a paper in which he speculated about the possibilities for an advanced civilization to capture and use all the energy emitted by its star. This was a revolutionary idea, proposing that to truly thrive, a civilization must expand its energy consumption beyond its planet's limitations. A Dyson Sphere, as it is commonly envisioned, would involve enclosing a star completely with an array or swarm of solar-collecting structures. This could be imagined as a gigantic shell or, more feasibly, a scattered orbit of panels that absorb the star's energy and convert it into usable power. The energy harvested from such a structure would be astronomically vast, far exceeding any resources currently available to us on Earth. However, constructing a Dyson Sphere is not just about technical challenges. It's about reimagining the future of energy and civilization. To appreciate its potential, we must first consider our current and future energy needs. As the global population grows and technology advances, our demand for energy increases exponentially. Traditional sources, such as fossil fuels, are finite and cause environmental harm, while even more sustainable options like wind or hydro are geographically limited. Here, the sun, which radiates about 384.6 yottawatts of power, offers a tantalizing solution. A Dyson Sphere could theoretically provide billions of times the energy our civilization currently consumes. But how do we convert this stellar output into a practical resource? First, it's essential to understand the construction hurdles of a Dyson Sphere. A solid shell encircling the sun is scientifically implausible with today's materials, as the gravitational forces and immense heat would likely cause any known substance to buckle. Instead, the concept of a Dyson swarm provides a more viable alternative. This would consist of a vast number of independently orbiting solar panels or satellites, potentially sourced from materials available in our solar system, such as asteroids or other planets. The logistics of building a Dyson swarm are equally mind-boggling. We would require advanced robotics, artificial intelligence to manage the complex operations, and efficient transport technologies, none of which are yet fully realized. Additionally, the financial and resource investment would be unprecedented. The swarm would need to be coordinated with precision to avoid collisions and maintain optimal positioning for energy capture. Despite these enormous challenges, there are encouraging signs of progress. Advances in space technology, robotics, and artificial intelligence are setting the foundation for future endeavors. Moreover, the idea of in-space manufacturing, constructing elements in outer space rather than launching them from Earth, could mitigate some logistical barriers. Imagine a future where a Dyson Sphere exists. Energy scarcity would become a relic of the past, possibly causing a paradigm shift in society. With such a surplus of energy, we could feasibly power giant space refrigeration units to tackle climate change, support world-ending human settlements on other planets, or even drive the creation of new digital worlds, harnessing computational power we can barely conceive today. Moreover, achieving such a scientific milestone would mark the transition of humankind to a Type II civilization on the Kardashev scale, a measure of a civilization's level of technological advancement based on energy consumption. Currently, we are hovering around Type I, relying mostly on Earth's resources. Harnessing a star's energy would propel us into a new era, rendering humanity virtually immortal in its ability to power the future. In conclusion, while the idea of building a Dyson Sphere remains in the realm of ambitious dreams, it serves as a powerful symbol of human capability and potential. Though formidable barriers exist, the exploration of such concepts inspires innovation and forward thinking, essential to solving the energy challenges of today and beyond. Through the lens of a Dyson Sphere, we glimpse the boundless possibilities of harnessing the cosmos, promising a revolutionary leap for human civilization.